Hello again. We're working with the cosine of theta. You can call it the cosine of x if you want to, if it makes more sense to you. And you should probably do this, put it in parentheses. So anyways, I made myself a table and I made myself a graph, and we're going to go ahead and graph this together. It's very similar to the sine function, actually. It's the cofunction of the sine. So there's going to be a strong relationship between the sine and the cosine. Maybe you'll notice it. Maybe you've already noticed it before. But I'm going to go ahead and plug in the values. I'm going to plug them in radians, and I'm going to plug them in increments of 45 degrees. But I don't like writing degrees because I think it's improper. That, and also because your books also tend to use radians too. So if you're always acclimated only in degrees, you'll never actually figure out what's going on here. Radians are just a different way to write degrees. That's it. The period of this function is the same as the period of a sine function. It's 2 pi. It's also the same as a secant and a cosecant. They're all 2 pi. At least the parent function is. If you manipulate the period, then obviously the period is going to change. Anyways, let me go ahead and plug in the values. So the cosine of 0, and by the way, you got to know your 45, 45, 90 triangle in order to know this. You got to know your unit circle as well. A lot of people say, oh, I don't know what the 5 pi over 4 in my head is, the cosine of that. That's stuff that you got to figure out. And I don't mean to be mean-spirited about that, but that's a basic. That's a trig basic, and at that level, if you're taking a class at that level, you got to be able to memorize that. If you don't know it, you got to be able to memorize it. Everybody had to. It's the same thing. Sometimes teachers give you tables. If they do, that's even better. But if they don't, which they probably wouldn't, you gotta memorize it. Anyways, the cosine of 0 is 1. Cosine of 0 degrees, or 0 radians, I should say, is 1. Relationships in sine and cosine are cofunctions. At 45 degrees, they're complements and cofunctions. Bam. Just root 2 over 2. In fact, I know every increment of 45 degrees that doesn't include a quadrantal angle, 0, 90, 180, 270, 360 is root 2 over 2. So this is also root 2 over 2. Don't correct me just yet. Root 2 over 2, root 2 over 2. I'm well aware that this one is negative, this one is negative, and this one is positive. I know that. In order to kind of figure out that a little bit better, it is better to actually figure out the main quadrantal angles, the ones that are on the y and the x-axis. The cosine of 0 radians is 1. The cosine of pi over 2 radians, or at 90 degrees, is 0. The cosine of pi, or 180 degrees, is negative 1. Cosine of 3 pi over 2 is 0. Cosine of 2 pi going back to the beginning is 1. So if you want to figure out what's positive and negative, this is another way to do it. You're going down, root 2 over 2 is 0.7. 0 to negative 1, oh, that means we're going to be hitting a negative number in there. Hey, we're going up, but we're still in the negative range. And we're going from 0 to 1, so the middle of it has to be positive. So that's a way of looking at it. Very similar to the sine function, like I said. 0, 1, right here. Pi over 4, root 2 over 2, right there, there. And it seems like I'm just starting over again. 3 pi over 4 is negative root 2 over 2. That means that's going to be negative 1. That's there. Let's see, that's 2. Yep, that makes sense to me. This goes here, and this goes here. So what's really interesting about this function, I didn't draw it perfectly, unfortunately, is that it looks like this. If I were to keep going, it would go like this. If I were to keep going, it would go like this. Nothing too special about it. Actually, it looks exactly like the sine function with a couple stipulations. One, the sine function starts at 0 when we're not playing around with anything. The cosine function starts at 1. So what I used to do before I became really acclimated with this, really familiar with it, is I just drew the sine function, except I started at 1 and just made a wave. Usually my teachers just accepted it. A sine function starts here, a cosine function starts here. Other thing that's very interesting is that if I had gone here, basically what I'm doing is if I shifted 90 degrees to the right, then this would be a sine function. That's in fact what it is. I mean, here's my graph, and then that's a sine, yeah. All I gotta do is really just shift it this way. In fact, cofunction angle is pi over 2 minus theta. We already talked about that. That's not terribly important, to be honest. All you got to really realize is that instead of starting at 0, you start at 1 for a cosine function. And then if you want to look at it from a different perspective, it's like shifting it over. So if I just shifted this function over here, 90 degrees to the right, it'd be set. So it's something for you to think about. Other than that, that's pretty much it. interesting function. We're going to talk about the secant function, which is the reciprocal of the cosine. Very short lesson. Not going to focus on amplitude, period, phase shift, or vertical shift, because I did that with the sine anyways. And you can apply it, all the same similarities in that respect to the sine. With that said, have a good day for now.